Okay, let's get started so I can get you guys on your weekend. So today we're going to start talking about for loops, which is exciting because now we're going to have if statements and for loops, which means we comprehensively have all of the control structures that we need to actually start programming. So hooray! The examples that we're going to be doing from now on will be a little bit more sophisticated than just sort of using Python as a calculator, which is exciting for us. A little word on strings and string methods and built-in methods, and specifically those things in relationship to assignment 1. At this link here, you can go and look at the Python documentation for built-in string methods. That is something that you can use in Python without calling external libraries, like addition, absolute value. Those would also be considered built-ins. So for example, if you have like a string, Steven Universe, and you want to capitalize that, you can say dot capitalize, and it will capitalize the very first character of that string, and only the very first character of that string. You can sort of count the E's in this string, and it's going to say 4. And you can ask where the first E is, and that's going to say 2. Right, so there's maybe 100 of them that you can go look at. Because I've been reading on Piazza, and it seems that this method where you have to check if the input string is a number is like freaking everyone out. So first, no, you are not allowed to use a try-catch. Right? That's trying to use like a mallet on a mosquito. Right? You have the tools required to solve this problem. Right? So just think a little bit harder. And since I know you probably won't do that, I'm going to give you half the answer. Right? So there's this string method. I'm just pulling these out at random from that page, which allows you to test if a string is comprised only of digits. So 1, 2, 3 is individually comprised of digits, so that's true. Unfortunately, if you put a decimal in there, it's going to say, oh, that this is not comprised entirely of digits, so that's false. However, you can find where the period is, or the decimal. You know that's at the third position. I don't know how knowing that and using string slicing in accordance with this is digit is going to help you, but maybe string slicing in accordance with this is going to help you. I don't know why else I'm telling you this, but you can find E in that number. Did you know that's a number? Do you know that you can type into Python something like 1.23 e to the 10? Right, and that's a scientific notation. So isn't it cool that you could find the E, and that it tells you it's at the 7th position? So maybe you could use these things in accordance with string slicing to solve the problem. One more thing. Any number starting with a 0 isn't a number. Maybe that should be something that you think about when doing assignment 1. Because we give you maybe 2 or 3 test examples in these headers, right? Our code is going to run like 1,000 examples on your code. So just because you satisfy the 3 or 4 test examples in the header makes no assurances that your code is going to work when we actually give it the larger test set. So you have to think, are there edge cases that could really trick me up here? Like a leading 0, the inclusion of an E. All right, so maybe think about that a little bit. But if I see a try, I'm going to write the code to try-catch your try-catches. I hate try-catches with every ounce of my being. Right? They should be used sparingly and only in very, very specific cases. Because, okay, this is a tangent. If you write a try code in your function, and your function does something dumb, which causes an error, you're going to say, ignore the error and continue, which could have like just crazy side effects for everything else that's happening around it. Yeah?
But what if you like catch a specific error?
That's much different. If you want to catch a very specific error, that may be okay. But this requires then you to go find that specific error, including the string which calls it, because sometimes you get an error, right? This name did this. So catching specific errors may be okay. But even in that case, the only time I've ever used the try-catch in my professional career is because someone else's code had an error in it. Right? Their code would fail on something which was guaranteed by their contract. So I had to say, because this code is going to fail for this method, right? So catch that person's error when his code flops, and then I'm going to do it for him, basically. That's the only time I've ever used the try-catch in my professional career. And every single code reviewer was like, why is this here? This should be removed, right? So it's not, this is very basically, as a last resort, you should be doing these, because your code shouldn't produce errors, like ahead of time, right? At what point would you allow an error to occur just to try catch it? Like there should have been something earlier on in that sequence that prevented the error from even happening. So that's really the only instance I can think of where a try catch would be absolutely necessary. I'm open to other examples if anyone has one. Yeah? No, but then you can even, like, odd in what way? Like you're taking some input from like a projector? I really can't think of. Anyways, this is off topic. Just no try catches for the assignment. I gave you basically the answer. Right? This plus string slicing, you got it. It's just a pattern match. And furthermore, if you're going to use functions that we didn't give you to cheat on the assignment, then at least cheat properly. Right? If you want, that you could use the regular expression package to check if something is a proper number, right? So if you're going to use extra tools, like at least go find the correct ones. But anyways, that's the answer to that question. I'm sure you guys can do it. Okay, so one more built-in string method that I didn't talk about when we introduced strings was this notion that we have ordinals and characters. So I mentioned to you that there's an organization called Unicode, which basically has listed all of the characters that a computer can accept and given them some type of ranking. And it turns out the ranking of the lowercase a is 97. I could undo this. I can ask, what is the character that is associated with the Unicode code 97? That's an A. I can ask, what is the character that's associated with the Unicode number 128,512? And let's just go check this out. So, this is pretty cool. What was it? 1,208, 512? That's cut off again? There we go. Just have to remember that this is how low everything has to be. Any guesses? Huh? Smiley face. All right, look, you guys have access to all the emoji, right? Oh, hold on. This is how you make me feel. This is how I feel on Monday. Oh, this is going to be incredible. No! Now I can't see what I type. Oh, hold on. I can still do this. I can integer cast this. What did I do? Okay, so while that runs, I just wanted to let you know that from now on, we're going to exclusively use emoji as input and output from our definitions. Yeah. Am I recording? Yes, I am recording. You seem disappointed. Like this is not worth the digital bits that it's being used to record. But even when I do forget to record this one, I have a lecture before this which I record. Oh, are you going to use this for evidence or something? Bring it to the dean. Anyway, so that gives you a smiley face. I couldn't find the 100 underline one because that's the one I wanted to print like 100 times. Anyways, so I can take characters. I can find their Unicode encoding, and then I can take the Unicode coding and go back to characters. So what would it mean then if I asked for the character that's 2 later from the ordinal of A? So I find the ordinal of A, that converts to a number, I think 97, plus 2 is 99. So what would be the character at 99 if Unicode were sensible?
Lowercase c.
Lowercase c is for cookie. It's good enough for me. Okay. So also remember that I showed you that these letters, these characters, have an ordering, right? So it was the case that little a was larger than big A. This is because the ordinal of lowercase a is greater than the ordinal of A. And so as soon as we convert these letters into integers, then we can use the normal integer comparison operations. The difference between the ordinal of A and the uppercase A is 32. I just want you to remember this value 32, right? That the lowercase letter is 32 Unicode characters later than the uppercase character, okay? Because now I want to write a function that converts a lowercase character to its capital. So let's give this a try. Okay, I'm going to have to kill this. So here's an interesting thing. If you need to, now that we're going to be using loops, you may in fact run a loop that, oh, it's been killed. That's too bad. No emoji for us. You can hit Control-C for cancel or Control-D for exit on all computers, right? Because eventually you're going to write a piece of code that you made a mistake in and will run forever. So if you need to kill it, it's Control-C or Control-D. Don't feel too bad. I was writing, this is going to be difficult. How much is cut off? A lot. Okay, so let me just, yikes, I'll have to look at that. Okay, so I'm going to touch a Python file and I'm going to open it. So now I can start coding. At least that's low enough. Okay, so what I want to do is take something and convert it to a capital, lowercase to its capital. So to capital, and look, I fixed my syntax highlighter. So I can take C, a string, and move that to a string. I want to return something, so converts a lowercase character to its uppercase. Here's some examples. Well, let's assume input is a lowercase character. I'll just give one example. So to capital of, let's say, small k, you get capital K. Okay. How do I fill this in? One line. How do I convert from a lowercase character to an uppercase character, knowing that they're separated by 32? Perfect. Let's give that a try. So I'm going to go into here, call in our Friday code to capital K. Perfect. To capital M. That's great. But notice I can give this anything basically. I can say exclamation mark, and it's still going to push it up and down. But it violated our assumption, right? So I know a lot of you are really keen on writing exception handling. So why don't we make a well, do this instead. This will be our compromise. You can write in an assumption into your doc string, right? And this will furthermore put the responsibility on the user to give your function the correct thing. So you may see some of these assumptions on your exams and on future assignments. So that works. So let's move on. There's the answer to that. Okay, so suppose now I want to take that function and I want to write a function that takes a string and converts the whole string to capitals. Well, we're boned, because at the current moment we don't have a control structure that will help us do that. We would have to manually take the string and individually convert all of the characters, which basically violates the whole purpose of computer programming. So we're going to write this, but I'm going to put it aside for now so I can teach you about for loops, which is the control structure we need for solving this. So a loop is a control structure. And the other control structure we've seen so far is an if statement. And this control structure has the property that it repeats code. The if statement was a control structure with the property to allow something to skip code. This is going to be something that repeats code. A for loop, which is the one that I'm going to be showing you today, is a control structure that, given a group of elements with an order on that group, repeats code for every member in the group in that order. Right, so I don't care. You give me a collection of objects. I don't care what the objects are. The only condition I have on your objects is you have to tell me, you have to give them to me in some type of order. I don't care what the order is. It doesn't even have to make sense. You can say, here's 7, here's -1, here's 9, here's smiley face, here's the 100 emoticon. Right, as long as I know which one's first, which one's second, which one's third, that's fine. So any group or any collection of objects with an order in Python is called an iterator, right? Because you can iterate through that group. You can walk from one element to the next. So the general syntax for a for loop in Python is for some variable name in some iterator, and the only iterator we have at the moment are strings, right? So a string is an iterator. So it's going to walk through the name in iterator and run a piece of code each time it walks. So first basic example. I'm going to take for x in the iterator of A, B, C, and D. What's going to print?
A, B, C, and D.
A, B, C, and D. Okay, so I'm going to walk this. I'm going to trace this. So Python is going to run all the code up here, then get to this line and see, oh, I have to repeat something. I'm going to set the variable x to the first thing in the iterator, a. Then I'm going to walk into this code and print the value of x, a. Then I'm going to go back to here because I'm repeating something. I'm going to move down the iterator by 1, so set x to b. Then print x, that prints b. Walk back to the beginning, move on to c. X gets set to c. I'm going to print c. It's going to repeat this again, get to d. D, print d. Then go to here, and then the for loop's going to say, there's nothing left in the iterator. Stop. Question, what is the value of x at this position in the code? Okay, so there's two options here, right? Either Python locally scopes x to the for loop, meaning that the for loop is the only thing aware of x, or not. So we have a guess that it's undefined. Any other guesses? It's D. So in the Python language, these loop iterators aren't scoped locally to the for loop. So you have to keep in mind that when the for loop exits, the last thing in the iterator is going to be what your name has held on to. So sometimes this can create weird side effects in your program. So just be aware that these things have values. Something that gets very confusing for new programmers is the fact that you can put control structures in other control structures. So specifically, you can put a loop inside of a loop. So I'm going to define two short strings here, digits, 0, 1, and 2, and alphas, a and b. So digit is to 0, 1, 2, as alpha is to a, b, c, d, right? The alphabet, right? The things in the alphabet are alphas, right? So that this has a sensible naming convention. So what I'm going to do here is going to take d in the digits and then repeat a for loop which takes a in alphas and then prints d plus a. So we'll start slow. What's the first thing that gets printed? 0a. So let's reason this. Python walks to this line, it sets those variables. Python walks to this line and it knows that it should start repeating something. It will take d in digits and set d to 0. And then it will walk to this line and realize that it has to repeat something. And it will take a to be a. Then it will print the value of d plus a, which is 0 plus a. So that's the first thing that gets printed. What's the next thing that gets printed? 0b, and then the rest. So let's reason through this. So rewind back to where I just printed 0 and a. Python is going to walk back to here, right? So the loops get resolved from the interior loop outwards, right? So the loop in the innermost indent has to resolve first. So this a is now going to be set to b. It's going to print the value of d plus the value of a, which happens to be 0 and b. Then it's going to escape this loop. A will have the value b. It will go back to here. D is now going to be set to 1. And it's going to set now, A is going to repeat the whole loop. So A is going to be set to A again. And then it will print 1 plus A. Then 1 plus B, 2 plus A, 2 plus B. All right, so here's an example of how you can nest these things. Now, to show you two things, so indentation matters, right? So these for loops, the for loops have code that belongs to it. And what belongs to it is everything that's indented 1. So I'm going to move this print statement. I'm going to unindent it. I'm going to move it down a control structure, and we're going to review what the code does. With a caveat. I can't actually leave a for loop empty. So I just threw in a none. But you can just see that line as being empty, just not doing anything. I had to put the none in or the compiler would reject this. So I've moved this print left 1 tab. What will be the first thing that's printed? Let's walk through it, okay? So Python walks to this line and sets those variables, digits and alpha. Python gets to this line and starts up the loop. It sets d to 0. It goes into this loop. It sets a to a, does nothing. Then it sets a to b and does nothing, and then exits. And at this point, we have d is 0 and a is b. So what gets printed first? 0b. And then that whole process will repeat itself, right? We'll go back to here. D will now get set to 1. This loop will basically do nothing twice. Escape with A equals to B, and then it'll print 1B, and then 2B. Okay, study these in the lab a bit. You really have to play around with these for loops. I'm going to move this print statement again left. Now what gets printed?
2B.
2B. Or not 2B. No, it's 2B. 2B. So note again that when these loops exhaust, the iterator maintains the value of the last thing in the group. So in this case, the print wasn't even in the loop structure. Like, print never got repeated. Print just got printed once, right? So this is actually a for loop that does nothing. Before we can return to this example where I wanted to convert things to capitals, I have to teach you about accumulation in loops. So an accumulator is a variable which a loop uses to accumulate or aggregate something, and it's very useful. So if I write something like this, ACC, that's short for accumulator. For strings, you usually start your accumulator at empty. So this is what I want to do in here. I want to say for x in this iterator, A, B, C, D, x gets set to A, and then accumulator gets set to empty plus A. So what does the first print? A. We're going to go up to here. X is going to get set to B. The accumulator is going to be set to A plus B. And then we're going to print that. So what do we print? B. We're going to go back up to here. X is going to get set to C. The accumulator is going to be equal to AB plus C. We're going to print that. ABC. Repeat it again. ABCD. And then we've escaped. Right? So you see how we're accumulating a value as we walk through this loop. This is very typical. We're going to be building many of our answers by accumulating in this manner. Write a function that reverses a string when given a string. Don't use string slicing, because that would be totally trivial. But you should use a string slice would be the correct answer here. I'm going to start putting all of the code now on the website. The code that we're going to be writing in class is going to start being too complicated for me to stick on the slide. And you weren't able to copy paste anyway, so I think this is going to be a better solution. But let's write this reverse string function now. So define reverse string. I want to take some characters, which is a string. I want to return a string. What is happening? So I'm going to return some answer. So I like using the word answer rather than accumulator. I don't know why. You can pick. This reverses a string. Yeah, reverses a string. That's pretty easy. So I have to have some inputs. Reverse string race car gives me race car. Not a very good example. A plus to anyone who gets this reference. Reverse string bad wrong goes to anyone get the reference? Killing is wrong and bad. From this day forth, I'll stand for the opposite of bad wrong. No? All right. Go watch the movie Kung Pao. It's going to be on your exam. Anyways, without using string slicing, how can I do this? Right. So for C in C's, for character in characters. Right. So we just built the string by putting stuff on the end. How can I modify that procedure to get the string in reverse? What happens if I append the new character at the front? Shouldn't that work? Okay, so I'm just going to print the intermediate results. So do I have reverse string bad wrong? Right? And I'm just showing you what the accumulator has done. Right? It took the first thing, said, okay, B. Then it took A, and it said, okay, put that in the front. And then it took D, and it said, okay, put that in the front, put that in the front, put that in the front. And it was accumulating the word. It was just putting it on the front of the word rather than the back of the word. Right? So here's a simple way that we can reverse a string. Okay, so what have I shown you? I've shown you that we have a mechanism for repeating an action over a string. So let us now return to this notion or this function of converting a string with mixed cases into full case. Okay, so I'm going to delete this. So I did something stupid. So I had something called to uppercase, right, which took this. I just want to put it back. Return. What did I return? So this is character of ordinal C minus 32. Was that it? Okay, cool. So just imagine that I didn't delete that we had that left over. So now what I want to do is say to upper cases, right? All this stuff. So usually I have a personal naming convention that if I'm doing something to a single thing, if I'm doing something to multiple things, I use a plural, right? I can have X, which is one thing, or X's, which is a collection of things. So that's why I say this is a C, a single character, and this is going to accept C's, multiple characters. So that's something that personally helps me keep things organized in my code. It's going to return some answer here. Okay, so what does this uppercase need to do? Given a string with mixed cases, returns the string with each character its uppercase. Right? Some examples. To uppercase, something like kangaroo should give kangaroo. To uppercase, drop bear should become drop bear. Does anyone know what a drop bear is? That's what the Aussies called koalas. Because they're like tree bears that like fall on you. I swear to you that they call koalas drop bears. And that's not the most ridiculous thing either about Australia. I could give you an hour lecture about that. I also didn't specify what should happen on non-characters, right? So if you don't specify it, you should just leave them alone, right? So this should be 1, 2, 3, go. Okay, so how can we now do this? So I'm gonna instantiate some accumulator called answer, and we're going to have to somehow loop through our characters. So what is the goal here? I need to go into my string, and if the case of the character is lower, I need to make it an uppercase. So the first thing I need to do is determine if C is lowercase alpha. How can I do that? So this is one way of doing it. Which is perfect. But I'm just going to make one simplification to this. We don't actually need to put the orders, right? Because the comparison operation is already going to use the order to do the comparison. So, oh, and that shouldn't have been a C in quotes. It should be the name C, right? Okay, so if the character I'm looking at, C, is in between A and Z, then it's a lowercase character that's an alpha. Okay, so in this case, what do? I need to say the answer gets answer plus, what do I do to C? Remember, let's be lazy programmers, which is the correct way of programming, incidentally. We wrote this before, earlier in class. So yeah, let's just use it. To uppercase C, right? And then else, what do I do? So I've looked at the character, it's not a lowercase alpha, so I should just... What should I do with non-alpha characters? I just don't touch it, right? Answer plus C. Okay? And let's just print out the intermediate results here. Okay, so what did I have? I have called this. Okay, so let me just first check my to uppercase. is working. Perfect. 2 uppercases, kangaroo. Perfect. So these were the intermediate results that are being printed, and that's what the function has returned. So you see, it's just accumulating the larger case characters as it's walking through. We can try one of the other ones. 1, 2, 3, go. And that works as well. So I'm just going to go back into here, delete this print, which I'm using for debugging purposes, and just give that another try. 1, 2, 3, go. Kangaroo. Right? So we're now beginning to write some less trivial type of code. Okay, in the next 15 minutes, I want to show you how to encrypt and decrypt something. Right? So cryptography is a huge field in mathematics and computer science. It is the reason the internet works. It is the reason you can do a secure credit card transfer. The mathematics behind it is spectacularly beautiful. It is the only mathematics that any politician has ever tried to make illegal. Right? I don't know how you can make an idea illegal, but there are institutions which have tried, because it is just that powerful of a method. I would need to teach you about a semester's worth of number theory in order to get you to a point where you could understand current cryptography, but you could certainly understand the Caesar cipher, which is one of the first examples of encryption that we can find in history. Now, the Caesar cipher is very easy. You just take a character and you bump it up or down the alphabet by some fixed length. Some more language about encryption. So the cryptography people like to define, so you have a message which you want to encrypt, and that message is called plain text. Right? The message is in its plain form, plain text. You take a plain text message, you put it through some encryptor function, and out pops some encrypted message, and that encrypted message is called the ciphertext. Then you want to be able to take that ciphertext, put it into the decrypt function, and get the plain text back. Right? So the notion about encryption is I want to somehow hand over a message from me to someone else so that anyone who intercepts that message in the meantime it will be useless, it will be gibberish. Okay, so I'll give you, a ciphertext or a Caesar text with a Caesar cipher with a shift of 1 would take A to B, B to C, D to E. Okay, that's not very interesting. What is interesting is we can shift backwards. So a Caesar cipher with a shift of -2 would take A to ZY, would take B to AZ, right, and so on. So what I need you to do is not imagine the alphabet is in a line, but instead the alphabet is written on a clock, right, where maybe you have A at 1 o'clock and you have Z at 12. Right? And then what I need you to do is imagine that we have one ring alphabet, and that on the interior of that we have another ring. And that I could rotate the one in the middle, and that there'll be pairings here. And that's basically how you cipher and decipher. And the amount that we turn by is going to be the shift. And I'm constructing it like this because we need to use the remainder. Right? I taught you something that I think I literally called clock arithmetic. And I didn't do this because I needed to keep you guys busy with like weird new mathematical operations. It's because we're often going to be in situations where we have some finite list of elements, and if you go off the end, they want you to come back to the beginning. Right? This is one of those situations. So in the last 15 minutes, I want to write code for encrypting and decrypting a message using the Caesar cipher. And I may have to go a little bit faster than normal because I only have 15 minutes. So the first thing that I want to do is define shift character. Right? And I want to shift a character C, which is a string, by some shift, which should be an integer. And I want to return a string after that. So let's return something. So what is my thing here? Shifts character C by shift according to the Caesar cipher encryption strategy. Okay? So what does this do? This takes something like shift character. Maybe it takes A, shifts it by 2, BC, so it should go to C. And maybe shift character of B at -2 should give you Z. Okay. This is going to be the hardest part of the whole program I'm trying to write. So I'm going to do this very slowly. So what do we need to do? There are three things we need to do. Given a character, I need to determine its placement in the alphabet. And then I need to shift that character in the alphabet. And then I have to correct in case it went off the end. So those are the three things I have to do. So what is the alphabet position of C? I know I can get its Unicode position. Okay, so think of it this way. I want to renumber the Unicode labeling so that A is 0, B is 1, C is 2, and so on.
You can make a string with the alphabet.
Simpler than that. So if I know that A is at 97, what do I have to remove from that to get it to go to 0? 97, right? What do I have to remove from B to shift it down? 97. So I'm saying if I know that A is here in Unicode, I can just pull everything back by that number, right? So I'm just going to take from here, I'm going to subtract the ordinal of A, right? Think about this. It just recenters everything. It just pulls everything back, right? So if I give this A, it's going to say A is at 0. If I give it B, it's going to say B is at 1. Okay, so I know the position in the alphabet of the character coming in. That's this. Okay, now I need to shift it in the alphabet. Okay, so I'm going to shift it in the alphabet. Okay, but what happens here? If my shift can push me off the end of the alphabet. However, I said let's put this on a circle, right? So that if I'm at 25 and I add 1, I should get to 0. If I'm at 25 and I add 7, I should, oh, that was too much. If I'm at 25 and I add 2, I should get 1. What operation do we have that does exactly that? It's called clock arithmetic, modulus, the remainder. It's the remainder, right? So if I'm at character 29, that's actually character 29 remainder 26, which is 3, right? That's anyways. You have to think about this a bit, but I've put the alphabet on a clock, and the remainder is the thing that allows you to reset that. So I'm going to say modulo 26, or remainder 26. There are 26 letters in the English alphabet. Okay, so that gives us our shifted position in the alphabet. Now I need to get the Unicode position. How can I get back to the Unicode position? Well, how did I convert from Unicode to alphabet? I subtracted the ordinal of A. So how do I get from the alphabet back to the Unicode? I have to add the ordinal of A, right? Oh, and spell alphabet correctly. Alpha. Yikes, bet. Okay. Keep that up and all of my variables will be called screw you students 1, screw you students 2, right? Alphabet position, Unicode position. Okay, we're back on track. So the Unicode position is the alphabet position plus the ordinal of A, right? And then I should just be able to return the character that's at this Unicode position. Okay, so let's cross our fingers and give this a test. So what did I call this? Shift character? So I have shift character A by 1, B. Shift character A by 3, D. Shift character B by -7, U. Perfect, I assume. So now that we have shift character, I have 10 minutes to do encrypt Caesar. And I'm going to take some plain text messaging, encrypt Caesar. I'm going to take some plain text messaging, which is a string, and I'm going to take some shift, which is an integer, and I'm going to return the encrypted string. Okay? This is going to encode plain text using the Caesar encryption strategy. Assumes plain text contains only alphas, and remember that is these characters, and spaces. Okay? and spaces will be left alone. Okay, so here, let's put some .code examples. Encrypt Caesar. I'm going to give it maybe ABC. I'm going to ask this to shift by 1, and this should return BCD. I'm going to encrypt Caesar. Encrypt Caesar. Maybe DE ABC, and I'm going to shift maybe by -3. So A goes to ZYX. So this gives XYZ. Okay. So here's an answer that I'm going to accumulate. I'm going to return this eventually. So what do we need to do? Okay, so I need to walk through each character of my plain text. Okay? And I just want to skip over spaces. So I'm going to say something like, if C is a space, then just don't touch it. Just accumulate it. Else, if C is not a space, it's my assumption that it's going to be a character. Yeah? Yes. Thank you. Else, I want to take answer and add to it the shift of C, the shift character of C by shift. Okay. And then I want to return the answer. So let's see. Let's call that in to my thing. Let's see if it's working. So now I want to Caesar. I want to encrypt. I need some type of. Okay, I'm going to shift by -5 maybe. I need some secret message that I'm ashamed of. Like, I don't know, Drake is overrated. Oh, okay, so I'm going to send this to my friend. Right? So there's the encrypted message. So, okay, I've encrypted. So now I have to write a routine for decrypting. Decrypt Caesar. And remember, we're going to be lazy programmers. How can I be lazy and write the code for this? There is a very trivial solution for this problem. The decrypt Caesar, all the decrypt Caesar does is the exact same thing that the encryption does. Exactly, but it just shifts in the opposite direction, right? So it would be bad to rewrite this, it would be bad to write a function that's identical to another function. Right? But it's okay to write a function which, well, like decrypt Caesar, which the name is telling you what it's doing, even though it's just doing something small. So let's just go into here. I'm going to kill this. It's going to go back into Python. So there's my encryption. There's my decryption. I'm just going to take this, give it -5. Oh, I screwed up something. X-rake is overrated. I got the exact same error the other night. What have I done? Oh, okay, I screwed something up with my capitals then. That's what seems to be the problem. Okay, so I'm just going to change my assumption. Contains only lowercase. Maybe you guys can go and fix this so that it accepts uppercase. Okay, so I'll try again. Encrypt Caesar Drake is the best. Just to please everyone else. -5. So I have this. Oh, I shouldn't have put an exclamation mark. Then I can decrypt this. That works out anyways. Is the best though. I have lots of Italian friends. Next week, more on accumulators and condition checking. You guys have a safe and nice weekend. I'll see you next week.